Hello folks, and welcome to your first flipped lesson. So we're going to jump right in and tie into our factoring. So you know what? Start the tractor. It's time to factor. So now we're going to take equations that involve polynomials, and we're going to solve them by factoring. And we'll also talk about identifying the multiplicity of roots. So we're going to jump right in here with number one. And take a look at factoring and solving polynomials. Notice it has to be equal to 0. Okay, so always set it equal to 0 first. And then always check for a GCF. Okay, after that. So no GCF. So I'm going to factor this trinomial into binomials. X squared I know is going to be x and x. I need two numbers that multiply to negative 15 and add up to negative 2. So I'm going to go minus 5 plus 3. Now to solve, I set each one of these equal to 0. And we can get our two solutions, 5 and negative 3. And there you go. That's our first solving by factoring. Set it equal to 0. If there's a GCF, pull that out and then factor. Alright. Now, this next one, I'm going to have you take a shot and go ahead and try to solve this one by factoring. The video will pause and there'll be a spot for you to put your answers in just a moment. Alright, hopefully things went well, but if not, you can take a look here for just a moment if you want to run through your problem, and then you can pause it and then we can keep moving. Alright, so moving on. Next problem. Alright, here we go. Now notice, in this problem, it's not set equal to 0. So I'm going to move the 4 over. And there we go. So now I can factor this. X to the 4th is x squared and x squared. Two numbers that add up to negative 8 and multiply to 16 are minus 4 and minus 4. That'll give you 16. And then negative 8x squared when you distribute this out. Now this one you got to be careful. So it's always important to remember to factor completely. Right? If you start the tractor and time to factor, why stop? So x plus 2, x minus 2, again, difference of squares, x plus 2, x minus 2, x plus 2, x minus 2 again. Another difference of squares. So when I look at this and I set all of these equal to 0, I'm actually going to get x equals negative 2, x equals 2, x equals negative 2, and x equals 2. So I get 4 solutions because it was to the 4th power, the original expression, 4th power 4 solutions. However, some of my solutions appear 2 times. And this is going to be something called multiplicity. If an answer appears more than once, it has a multiplicity of however many times it appears. So x equals negative 2 has a multiplicity of 2, and x equals 2 has a multiplicity of 2. Again, that still gives me 4 solutions to match the 4th power, but some of the answers are repeated. Some of the solutions are repeated multiple times, thus multiplicity. Alright, moving on. So here's another one for you to attempt. The video will pause and you will have a chance to solve on your own and enter your solutions. Then continue the video. Alright, so you entered your answers. Here's some feedback. You can see whether or not you are right or wrong. Pause the video, take a look at how it's done, and then move on to another example. All right, number 5. Now, sometimes you may have to expand out or distribute your problem in order to get it equal to 0. So my distributive property here will be 8x squared plus 12x minus 2x minus 3 equals negative 3 if I use my distributive property. Now, combining like terms, plus 10x, if I bring the minus 3 over, by adding 3, I'm going to get 0, so I'll have 0 on the right. And now I can factor with a GCF of 2x, pull out the 2x, and now set each factor equal to 0, and I come up with 2 solutions, one of 0 and one of negative 5/4. So this is an example of where you have to maybe expand out, distribute before you can set the equation equal to 0. Okay? No multiplicity, no repeated roots. My original expression was quadratic, so indeed I had 2 solutions. Very good. All right, so I'm going to pause the video again. All right, hopefully you found some success, you entered your answers, and here's some feedback for you on whether or not you're learning how to do the distributive property before you solve and set the equation equal to 0. All right, one last idea today. I want to just look back at example 3 and talk a little bit about multiplicity and exactly what it means. So one thing that multiplicity will help us with, again, multiplicity is when a factor in an equation occurs more than one time, okay, more than once, multiple times, then it has multiplicity. So the multiplicity can really help us when it comes to graphing and understanding solutions and how that looks on a graph of a function. All right, so when something has even multiplicity, 2, 4, 6, 8, that means if you look at the graph, at those points, it will touch the x-axis but not go through it. If a graph has odd multiplicity, it occurs 1 time, 3 times, 5 times, it will cross the x-axis and it will bend. Okay? In other words, if it has 3 solutions, if something has a multiplicity of 3, its graph will cross and bend 3 times. If it has even multiplicity, like of 2, it will touch at those places but not cross. Okay? So let's take a look at an example. We'll go back to number 3. Okay? This was number 3 in our problem. So it was x to the 4th minus 8x squared plus 16 equals 0. Now instead of solving, I'm going to show you a graph here, maybe, of this. Right here. Okay. As you can see, I have graphed this function, and notice this graph hits twice. The 2 places it hits are -2 and 2, but it does not cross the y-axis. If you think back to our function here, I'm going to capture this for us. Come on back. And there it is. Notice this graph has a multiplicity of 2 at x equals -2. So it touched the x-axis but did not cross. And it had a multiplicity of 2 at x equals 2. In both cases, and it's a little cut off here, but you can see that it touched the x-axis but it did not cross. Let me go back to this graph. I think you can see it a little better. Okay, right here and right here. -2, 0, and 2, 0. Touches but does not cross. They had even multiplicity. And we're good to go. So, practice today. We're going to have a worksheet. It's important that you do numbers 1 through 16. We're actually going to add to this 15, 16, 17. So you'll actually have 1 through 17. Awesome. You can always watch this again. Take care. Have a great Tuesday.